Right now, as you're listening to these words, you are moving, not walking, not running, but racing through space at speeds that would make a bullet seem lazy. The chair beneath you, the ground beneath that, the entire earth itself, spinning eastward at more than 1600 kilometers per hour. You've traveled half a kilometer through space in the time it took you to listen to this sentence. You don't feel it. The motion is so smooth, so constant, that stillness and speed become the same experience. But the universe knows. Every atom in your body remembers. This is a contemplation about that motion, about the turning that never stops, about spin, the quiet heartbeat of existence, and how it writes time itself into the fabric of everything. When we talk about time, we often imagine it as something separate, an invisible river carrying us from past to future. We measure it with clocks, mark it with calendars, feel it in the graying of hair and the lengthening of shadows. But time isn't something the universe has, it's something the universe does. And what it does, more than anything, is turn. Think about how we measure a day. We count one full rotation of Earth. A year, one complete orbit around the Sun. A second, measured by atomic clocks, is defined by the oscillations of cesium atoms, tiny quantum spins flipping back and forth with such perfect regularity that we've built our entire civilization's timekeeping around them. Every measurement of time is a measurement of rotation. Every tick is a turn. Every moment is marked by something spinning. The Earth completes its daily rotation, and we call that passage time. But beneath that simple motion lies something profound. The planet's spin doesn't just mark time. It creates the conditions for time to have meaning. Without rotation, there would be no rhythm of day and night, no seasons, no cycles to anchor our experience of before and after. But Earth is just one spinner in an endless cosmic ballet. The Moon orbits our planet once every 27 days, locked in a gravitational embrace so perfectly balanced that it always shows us the same face. Together, Earth and Moon race around the Sun at 30 kilometers per second, fast enough to cross Earth's entire diameter in under 7 minutes. The Sun itself isn't standing still. Our star, along with hundreds of billions of others, orbits the center of the Milky Way galaxy at more than 800,000 kilometers per hour. One complete galactic year takes 230 million Earth years. The last time our solar system was in this spot in space, dinosaurs had just begun their reign on Earth. And the galaxy? It too is moving, pulled toward a massive gravitational anchor we call the Great Attractor, part of a vast web of galaxy clusters all flowing together through invisible currents of cosmic gravity. Everything turns, from the smallest electron to the grandest supercluster. Spin is woven into the architecture of existence. But here's where it becomes strange and beautiful. When things spin fast enough, time itself begins to bend. This isn't metaphor, it's physics, the strange, verified truth that Albert Einstein revealed more than a century ago. The faster something moves, the more slowly time passes for it. And spin is motion. Every point on a rotating object is traveling through space, and that motion affects the flow of time. On Earth, this effect is whisper quiet. A clock at the equator moving faster than a clock near the poles because of Earth's rotation ticks ever so slightly slower. The difference is measured in billionths of a second per day. Invisible to human experience, but absolutely real. Scientists have measured this with atomic clocks. So precise they can detect changes smaller than a trillionth of a second. Place one clock at sea level on the equator and another near the pole, and over time they drift apart, not because one is broken, but because they exist in different slices of space-time, carved by Earth's rotation. This tiny discrepancy isn't academic. GPS satellites must constantly correct for it, without accounting for relativity, for the way motion bends time. Your phone's navigation would be off by kilometers within a single day. You are living inside this effect right now. Depending on your latitude, your altitude, your position on this spinning world, time is flowing at a subtly different rate than it is for someone elsewhere. You'll never feel it, but the universe keeps perfect account. Now imagine spinning something much, much faster. A neutron star, the collapsed core of a dead sun. Barely 20 kilometers wide, but heavier than our entire sun, can rotate hundreds of times per second. Some complete a full turn in just a few milliseconds. At these speeds, time dilation is no longer subtle. A clock on such a star's surface would tick dramatically slower than one floating in deep space. What feels like a second there might be many seconds here. The star's immense gravity deepens this effect even further. Gravity too bends time, pulling it slower the stronger the field. These stellar remnants are called pulsars because their rotation creates lighthouse beams of radiation that sweep across space. Each pulse we detect on Earth marks a single rotation, a cosmic heartbeat so precise that astronomers use them as natural clocks, sometimes more accurate than anything we've built. But even pulsars are not the ultimate spinners. At the edge of possibility lie black holes, regions where gravity is so intense that not even light can escape it. And many of these cosmic monsters spin fast. Some rotate at more than 99% of the speed of light. A spinning black hole, what physicists call a Kerr black hole, doesn't just bend space-time, it drags it. Around these objects exists a region called the ergosphere, where space itself is whipped into a frenzy. Nothing can remain still there. Even if you fired engines in the opposite direction with all the energy in the universe, you would be carried around with the spin. Space-time itself is moving, and you must move with it. This is called frame dragging, and it's not theory anymore. It's been measured. Even Earth, our gentle, slow-spinning home, drags space-time ever so slightly as it rotates. NASA's Gravity Probe B mission confirmed this in 2004, detecting the tiny twists our planet makes in the fabric of reality. But near a spinning black hole, frame dragging becomes violent. Time and space intertwine so thoroughly that moving against the spin means moving backward through time, something that would require infinite energy. The flow of time itself is locked to the rotation. Stand near such an object if you could survive, and you would discover that time is not your own. Every second you experience would be stretched, distorted, woven into the black hole's spin. You would exist in a different timeline than someone far away watching you from safe distance. This principle scales across the cosmos in ways both subtle and profound. The Milky Way galaxy, our island of 200 billion stars, rotates like a vast pinwheel. Every star, including our Sun, orbits the galactic center, and because of this, different parts of the galaxy experience time at different rates. Stars closer to the center move faster and live in a deeper gravitational well. Their clocks tick more slowly than those of stars farther out, like our Sun, residing in the quieter suburbs. The difference is microscopic, but over billions of years, it accumulates. Our galaxy doesn't have a single universal time. It has a gradient, layers of time flowing at different speeds, all synchronized to the beat of its rotation. In a sense, the galaxy is like a vast, invisible time machine. Not one that lets you travel between eras, but one that stretches the experience of time across its structure. And galaxies themselves interact through their spins. When two collide, a process that takes millions of years, their angular momentum doesn't vanish. It combines, reshapes, creates new forms. The Milky Way galaxy has consumed dozens of smaller galaxies over its lifetime, each merger leaving fossil streams of stars orbiting at odd angles, memories of ancient spins absorbed into our own. In 4 billion years, the Milky Way and Andromeda, the nearest galaxy to us, will merge. Their spins will intertwine. Their stars will spiral into new configurations, and the combined galaxy will carry the memory of both rotations in its new form. Time will continue, but the clock will have been reset, rewound, and set spinning again in a new key. Spin doesn't only exist in the vastness of space. It lives in the quantum realm at scales so small they challenge imagination. Every fundamental particle, every electron, every quark, every photon carries something we call spin. But quantum spin is strange. An electron doesn't physically rotate like a tiny planet. Its spin is intrinsic, a built-in property as fundamental as its mass or charge. Yet this quantum spin determines how particles interact, how they form bonds, how they obey the deep symmetries of nature. The spin of electrons gives rise to magnetism. It determines why some materials conduct electricity and others don't. It's why the atoms in your body can form stable structures instead of collapsing into chaos. Without quantum spin, matter as we know it could not exist. And there's more. Spin at the quantum level is not symmetric. Nature has a subtle bias, a preference for certain orientations. This is called chirality, handedness. Some fundamental forces, like the weak interactions that governs radioactive decay, only interact with particles of one-handedness. This tiny asymmetry may be why the universe exists at all. In the first moments after the Big Bang, matter and antimatter should have annihilated each other completely, leaving only energy. But they didn't. A minuscule imbalance, perhaps tied to the orientation of spin, allowed slightly more matter to survive. From that asymmetry, everything emerged. Stars, galaxies, planets, life. All of it built on the foundation of a quantum spin bias so small it's almost invisible, but so profound it separated something from nothing. In the smallest things, the deepest mysteries spin. The arrow of time, the fact that we remember yesterday but not tomorrow, that eggs break but don't unbreak, that entropy always increases, may also be connected to spin. Most laws of physics work equally well forward or backward in time. Yet the universe doesn't behave symmetrically. Time flows in one direction only. Why? Part of the answer lies in thermodynamics, in the tendency of systems to move from order to disorder. But beneath that may be another answer, the asymmetry of spin itself. The fact that particles with one-handedness behave differently than their mirror images creates a subtle preference built into the fabric of reality. This preference doesn't create time's arrow, but it tilts the stage. It gives the universe a faint initial bias, and entropy follows that bias, turning it into the one-way current we experience as time. Neutrinos, ghostly particles that barely interact with anything, come only in left-handed versions. Right-handed neutrinos, their mirror twins, don't seem to exist in our universe. This isn't random. It's woven into the laws of nature. Time may not just be something that happens. It may be something that particles themselves enforce through their spins, their orientations, their subtle preferences for one direction over another. Time flows because the universe chose to turn. What would happen if Earth spun faster? If the planet completed a rotation not in 24 hours, but in 12 or 6, the sun would race across the sky. Days would compress. The equator would bulge further as centrifugal force pushes outward. Your weight there would decrease slightly. The equator would bulge further as centrifugal force pushed outward. Your weight there would decrease slightly, not enough to notice casually, but enough for physics to measure. Winds would become fiercer as the Coriolis effect strengthened, bending air currents into tighter spirals. Hurricanes would spin faster, storms would rage harder, and time, atomic clocks at the equator would lag further behind those at the poles. The relativistic effect, already present but tiny, would grow. The gradient of time across the planet's surface would steepen. Our biology would protest. We are written to a 24-hour rhythm. Hormones rising and falling. Body temperature cycling. Neurons firing in patterns synchronized to the spin of our world. Shorten the day, and you don't just rearrange schedules. You tug at the gears inside every cell. If Earth spun slower, the transformation would be equally dramatic, but in the opposite direction. Days would stretch. The sun would linger overhead for hours, then vanish for equally long nights. The temperature swings between day and night would grow extreme. One side baking, the other freezing, while the atmosphere struggled to circulate heat between them. Life evolved to the rhythm of this particular spin, 24 hours, give or take. It's written into our DNA, our circadian clocks, our very existence. Change the beat, and life must either adapt or perish. Our world turns at just the right speed, a gift we rarely acknowledge. In the end, all of this calms down to a simple, staggering truth. Spin is the cosmic clock. Time is not something separate from motion. It is born from motion, measured by motion, bent by motion. Every rotation, from the quantum flutter of an electron to the slow, majestic spiral of a galaxy, is a way of marking time. Every spin is a heartbeat. Every orbit is a cycle. Every oscillation is a tick. Remove all the spin from the universe. Stop every planet, every star, every galaxy, every particle, and what would remain? Perhaps time itself would lose its heartbeat. It might exist as a dimension, but not as an experience. The flow we know would fall silent. Spin sustains time. It keeps the universe from being a frozen, timeless void. It gives us mornings and evenings, seasons and years, memory and change. It is the rhythm that allows cause to lead to effect. that lets stories unfold, that makes existence dynamic rather than static. You are living inside the beat of the universe. When you stand outside tonight and look up at the stars, remember, everything you see is turning. The earth beneath your feet, the moon above, every star in every constellation, every galaxy scattered across the cosmos, all of it spinning endlessly, beautifully, in a great cosmic ballet that began nearly 14 billion years ago and has never stopped. Time is not floating somewhere beyond all this. It emerges from it. The universe doesn't tick, it turns, and with every turn, it carries us forward. The secret clock was never built. It cannot be stopped. It has no hands, no face, no numbers. It is written into the structure of existence itself, in the rotation of worlds, the spin of particles, the spiral of galaxies. This is the clock that keeps the universe alive. At this moment, you may feel still, but you know better now. You are spinning at over 1600 kilometers per hour. You are orbiting the sun at 30 kilometers per second. You are riding a star that circles a galaxy at nearly 1,000,000 kilometers per hour. You are part of a galaxy cluster moving through space at speeds that dwarf even that. And every atom in your body carries its own spin. Quantum rhythms so fundamental, they determine what matter is, how forces work, why chemistry happens. You are a universe of spinners, riding on a spinning world, inside a spinning galaxy, in a cosmos that has been turning since time began. Or perhaps more accurately, time began when the cosmos first learned to turn. You are still, and you are flying. The universe spins not because it must, but because spin is what existence does. To be is to move. To move is to turn. To turn is to mark time. Every sunrise is proof. Every season is a testament. Every heartbeat in your chest is an echo of the first rotation, the first asymmetry, the first moment when nothing became something and learned to spin. Time is not passing around you. You are part of time. And time is part of the great turning, the cosmic clock that has no beginning, no end, only the eternal now of motion. This is the knowing. Everything turns. Everything keeps time. And you, right now, listening to this, are one small perfect note in the universe's endless symphony of spin. The cosmic clock ticks on, and you turn with it forever.